So in the previous lecture, last time I have started this chapter number 1, and that chapter number 1 was related with physics and measurements. So I just go through this one and then we will move forward. So in chapter number 1, you remember that we have discussed some things. The chapter number 1 was related, this chapter number 1, and it is related with physics and measurements. So the most important thing is in this chapter is the measurements. So in measurements, you know that we have discussed with the length and mass and time. So these three things are important for us in this syllabus. So length, you can measure with the units of meter, centimeter, like this one. But if you want to measure the length with some instruments, you know that we can use the scale. We can use the scale. We can use the vernier calipers. Vernier caliper, maybe you have studied at your high school physics. And we can use the micrometer. So these are the instruments which we are normally using to measure any length. So scale, you can measure up to 1 centimeter. But if you want to go to lower value like millimeter, so you can use the vernier caliper, and for especially the micrometer is used for micrometer measurement. And similarly for mass, we are using the balance. So balances are of many kinds. One balance is very precise. You know that if you go in the this gold market, so their balances are very precise, and this balance is maybe 0.0001 up to this one. It can measure micrograms. And time you can measure with your stopwatch. This is with stopwatch. So stopwatch normally exist in the mobile phones or in the wristwatches. So we have discussed all these things and how length has defined and mass has defined and time has defined. And then I discuss with you the physical quantities and the fundamental physical quantities and their units. All these things I have discussed with you. And then we discussed how to write the numbers, and then the derived quantities, and then the most important thing in this chapter is the dimensional analysis. The dimensional analysis is very important. How to find the dimension of any quantity. So last time I have discussed with you some dimensions. So some dimensions you must remember, like area, like volume, okay, and like force. So these dimensions you must remember. And last time I have discussed that length we are representing by L, and mass we are representing by M, and time we are representing by capital T. Okay. So last time also I have discussed with you, if we have one equation, like if we have this equation that VF is equal to VI plus AT, so we can find the dimension of this equation. We know that VF or VI is the speed or the velocity. So if you know the units of any quantity, you can find the dimension. So speed is meter per second, okay? And the dimension will be meter, length, second, time. So we can write it LT minus 1. This is for the speed. So it means if this side is LT minus 1, then this must be LT minus 1. Then this must be LT minus 1. Otherwise, the equation is wrong. So AT mean what? AT mean A is the acceleration. It is meter per second square, and time is second. So 1 second will cancel with this one. The answer will be meter per second. So meter per second mean L over T, or you can write LT minus 1. So these are the things which you have to control. So last time I explained that meter can be added in meter. This is okay. But meter, if you write meter plus kilogram, this is wrong. This is wrong. So meter plus meter. If this unit is meter per second, it must be meter per second. It must be meter per second. Otherwise, this equation is totally wrong. So here you have to control all these things. Okay. After this, we have discussed that if we have this equation 1 over 2 AT square, so we can find the dimension. Okay. So the dimension of X will be what? This is the constant, and constant we neglect. We don't consider constant. We only consider AT square. So AT square mean meter per second square, and this is second square. This is the same thing. And this is cancelled. Second square will cancel with second square, and answer is meter. So meter mean its dimension is L. So last time I used some equations in which we have seen that how to find the dimensions. So you control these equations. Other is simple, I think. So one is X is equal to last time 1 over 2 AT square plus BT cube. He is asking what is the dimension of A, or what is the dimension of B? If X is the distance, we know that if X is the distance, then X dimension will be L. So to make it L, what we have to do? So the dimension of A will be what? The dimension of A will be L over T square, or you can write AT square is equal to L. Okay. And this is equal to A is equal to L over T square. So L over T square mean L over this capital T square. So dimension of A will be L over T square. If I put here L over T square, then T square will cancel with this T square. The answer will be length. So on left hand side, we have length. Okay. And similarly, you can see that BT cube. So to make it length, what we have to do? L over T cube. So T cube will cancel with T cube. The answer will be L. So the dimension of B is, in this case, L over T cube, or you can write LT minus 3. The dimension of L is, A is LT minus 2. So if they are asking that what is the dimension of A, what is the dimension of B, you will not write its dimension is L. No, you will write its dimension is L over T cube in case of B. And in case of A, it is L over T square, or LT raised to power minus 2. Okay. After this, some quantities have the same dimensions, like 1 over 2 mv square. This is what? This is kinetic energy. Okay. If I want to write potential energy, you have studied in your previous classes, it is mgh. If I want to write work done, then you know that work is force multiplied by distance. Okay. If I want to write here torque, maybe torque you understand, you have studied, but we will study in this syllabus, you will see it is also F into D. So if you see the units of kinetic energy, we normally said that the unit of energy, kinetic energy or work is joule. This is also joule. This is also joule. But this is not, we call it joule. Okay, what we call it here? Let's see later. No, see, joule is what? Newton multiplied by meter. Newton multiplied by meter. Newton multiplied by meter. It is also Newton multiplied by meter, but not equal to joule. We are not saying that the unit of torque is joule. We are saying that unit of kinetic energy, potential energy, work, this is joule. But torque is not joule. Okay. Understand this one. So if you know Newton into meter, you can expand it. You can expand Newton. So Newton is what? Newton is force. Force is what? M into A. M into A is what? Kilogram meter per second square. This is called Newton. And this is meter. So you can write this one kg meter square over second square. So kg is what? Mass, capital M. Meter square is what? L square. Second square is what? T square. So dimension will be what? M L square T raised to power minus 2. So this is the dimension of this kinetic energy, potential energy, work, or even torque. But torque is not equal to joule. Equal to Newton into meter. We are not saying that this is joule. Remember this one. Just remember. Okay, understand this one?
Yeah, it's clear.
So you have to remember some things. Remember, I mean that what is Newton? Newton is kilogram meter per second square. From where it comes? It comes from MA, because force is equal to MA. Okay. And similarly, you should know that work is what? Work is force into distance. And this is Newton and this is meter. And Newton you can write here and then solve it. This is the simplest way to solve any units or dimension. So remember in physics, this is very, very important. This is the general rule. If you know, in general, we are saying that if you know the rules of any game, either it is a football game or it is a cricket game or it is any other game, you can play. Otherwise, you cannot play. So remember, if you know the rules, how to check the units, how to check the dimension, you can solve problems easily. I think so. If you know the periodic table, you understand the periodic table exists in chemistry. You can understand chemistry very, very well. So these are the rules. Okay, here the rule is the units and the dimension. So your focus must be on the units and the dimension. How to find the dimension, how to find the units. Okay, so the conversion of units are very important. You know that in the previous lecture, I have given you that 1 kilometer is equal to what? 1000 meter. Okay, if you want to write 1 meter is equal to how many kilometers? You can write 1 meter is equal to 1 over 1000 kilometer. Okay. Similarly, we have discussed in the previous lecture that if we have 10, suppose millimeter. So what we will do? 10 into 10 raised to power minus 3 meter. Because milli mean 10 raised to power minus 3. If it is written 10 micrometer, so you can write 10 into 10 raised to power minus 6 meter. If it is written 10 nanometer, you can write 10 into 10 raised to power minus 9 meter. So when you go to the labs, here in this physics 103 labs, you will see when you are taking the data, The numbers are, sometimes the numbers are very small and sometimes the numbers are very large. So large numbers and small numbers both create problems. So what we have to do? We have to make them in scientific form or standard form. Okay. So scientific or standard form mean what? Mean, suppose you have this number like this one. So you can write this number that 1 into 10 raised power minus 3. If you have this number 0.003, you can write this 10 into 10 raised power minus 3. You will see in the columns your data. Here one column, here second column. Here the numbers are like this one, 1 into 10 raised power minus 3, 3 into 10 raised power minus 3. So normally you will see the teachers will put here 10 raised power minus 3 constant for all values. And they just write 1, 3, 5, 7 like this one, 0.05, 5 into 10 raised power minus 3 and 0.007, 7 into 10 raised power minus 3. They will make it like this one. Why they are making like this one? Because it is easy, it is simple to draw the graph to find the values, because this number is constant with all values. Okay, so that's why we are studying here the standard form of the numbers, the prefix form of the numbers. The journal or the ordinary form is we don't need. If we have like this number, like this, so what we will do? We can make it 1 into 10 raised power 1, 2, 3, 4 into 4 meter, like this one. But if you want to make this number in prefix form, what you will do? You will write 10 into 10 raised power 3 meter. I split this one into 1 and into 3. So you can write this one 10, and this is what? Kilometer. You can write it 10 kilometer. So this is your prefix form, and this is your standard form, and this is your ordinary form. So frequently we are using the standard form or the prefix form during the experiment, during the calculations. So that's why we are studying all these things. Okay. So after this, you can see that if we have this type of, I already explained this one, that x is equal to ATQ plus BT square plus CT. And he is asking that x is the distance. X is the distance. If x is the distance, then we know that its dimension will be L. Okay. So what is the dimension of A? To make it L, what we will do? We will do L over TQ. To make it L, what we will do? L over T square. To make it L, what we will do? C is equal to L over T. So dimension of A is LT minus 3. Dimension of B is this one. Dimension of C is this one. So normally sometimes we write it in brackets, sometimes not brackets, but
Doctor, the L is the length.
L is the length, and length mean meter. Length is meter, centimeter, micrometer, millimeter, nanometer, but it is length. Okay.
Okay.
Yes, any question?
Yes, doctor.
Yes.
How can the question come?
Question come like this one. You can see in the previous papers and study, and then if you cannot solve the dimensional question or the units conversion question, then ask me. Okay.
Okay.
Yeah, you should ask me. But if you understand this one, I'm 100% sure that you can solve, because we are picking the pulse of the problems. We are actually studying the rules of the problems, how to control. This is like your steering of your car. If you control the steering, you can run the car as many speed as possible. But if your steering control is not good, you cannot run this car up to 60 kilometers per hour. Okay. And similarly, this is one thing which you have to control. Okay. The other thing is the units conversion. So in units conversion, last time I explained you infrequently, you will see that some units are giving in kilometer per hour. So you have to convert it into meter per second. So last time I told you that kilometer mean 1000 meter and hours mean second. You convert it hour into second. It is 60 into 60, 60 minutes and 60 seconds. Okay. So when you solve this one, cut this one with this one, you will get 10 over 36. And 10 over 36 means 5 over 18. So if the value is giving 72 kilometer per hour and you have to convert it into meter per second, what you will do? You will multiply it with 5 over 18. So when you multiply it 5 over 18, 18 fours the 72, 5 fours the 20. So your answer will be 20 meter per second. So this conversion is frequently used when you solve speed acceleration problems. The value is giving in kilometer per hour. You have to convert it into meter per second. Okay. So remember this one. This is very important. And some conversions are important, so especially this one, and in the feet and not in the inches is important, but centimeter is important. So 1 meter is equal to 100 centimeter. And 1 centimeter will be what? 1 over 100 meter. So remember this, 1 over 100. Okay. So conversion of units, two things you have to control: conversion of units and dimensional analysis. How to find the dimension. These two things are very, very important. Okay. So you should try to solve the problems as many as possible. And if in any problems you have a problem, then I will discuss with you and solve it. Okay. One thing. So if you have any question about this chapter number 1, you can ask me first.
I have a question, Doctor.
Yes, yes, yes.
Should we buy the book or just see the slides?
No, you don't. I think you don't need to buy the book. I send you the book. You open or not?
No, I didn't buy the book.
No. I send you by PDF.
Doctor.
Yes.
Yeah, the
Yeah, the
drive, the
slides.
Google Drive doesn't work.
Doesn't work. Okay. So this
Yeah,
is the problem. Okay. So I will send you again. Maybe with uploading, the file is corrupt.
Doctor?
Yes.
Yes, about the slides that you sent on the
link.
website from the, yes, the link.
Yes.
It starts with the chapter 2. There's no chapter 1 in the slides.
Yes. Okay. Go to Dr. Nasser Al Zayed. He has, I think, giving chapter number 1.
Okay, thank you.
Doctor, what do you suggest for us to study from?
Study from book.
The book, okay.
Book. The slides are just how many articles included in your syllabus. They have just briefly explained. Okay. Just see the slides, what is in the slides, and then go to the book. Book is very important for you. And then important is here. Understand from here on this platform.
Doc, I have a question. Can I ask, please?
Yes, you are open. You can ask as many questions as possible. I am coming
thank you.
online for you.
Okay, thank you a lot. Teacher, about today we have second physics class. Will
Yes,
it be online or we should go to the class or I don't know. So please.
I think, brother, 104, physics 104 and 103, both will be online in this semester. I think so.
But you are not sure, right?
I'm because the chairman is also not sure. How I can sure? I ask him.
Okay. Okay, thank you a lot, Doctor.
But if you have any question on this platform, you can ask me. But if you have any other problems when you will come for the lab in the university, you can visit my office. Okay.
Thank you a lot.
Yes, brother.
Excuse me, Doctor.
Yes,
How can I reach the pre-recorded lectures?
I send you, I think, recorded lectures.
Yes, yes.
Yes, doctor, we got it.
Yes, okay. But if you have any problem, you must tell me.
So doctor, you will send us another link for the book?
Yes, surely,
Thank you.
surely I will send you, and you must reply me that it is opened or not. Okay.
Okay,
Then immediately I will make an alternative. Okay.
okay. Thank you, doctor.
Yes, about chapter
Yeah,
number
doctor.
1. Yes.
Yeah, sorry, it's not about the chapter, but today we have the practical class. Should we attend
No.
the
Next
university?
week, next week, your practical starts. Next week.
Okay, thank you.
Next week must attend practical. Don't miss any practical class, because if you miss any practical class, you will be in trouble, because you have to do that practical with some other group and for another spare time. Yes. Hello.
Yes, doctor.
Yes, yes.
Yes. Any other question?
Yes, doctor. No, thank you, doctor. Appreciate it.
If you have any other question, okay. So I think it's better I stop here, and next time I start this chapter number 2, motion in one dimension. And this chapter has a lot of detail. You have already studied at your high school level, but here we will give you more concepts and more tedious things. Okay, because acceleration is not a simple thing. It's a tedious and difficult thing. And same is the velocity, and same is the distance and the displacement. Okay, so in that chapter, what we will do, okay, I just tell you in 1 minute. In chapter number 2, we will discuss the motion in one dimension. Either the body is moving like this one, or the body is moving like this one. This one is mean free fall. Okay, this is called free fall, and you know that free fall acceleration is g. If the body is moving like this one, then acceleration is a. Okay, if body is moving like this one, then acceleration is g. So we will discuss in chapter number 2, either the body is moving this side, or it is moving this side, or it is moving this side, or it is moving this side. Okay, so all these problems we will discuss in chapter number 2. Okay, understand? So if you don't have any more question, so I stop here and see you in the next lecture, and study your chapter number 1 complete. And if you have any question, we will discuss in the next lecture the questions of chapter number 1. Okay.
Thank you, doctor.
Thank you very much, doctor.
Thank
Okay.
you, doctor.
Okay. Assalamu alaikum.